Okay. Welcome, everyone, to the Allen School Colloquium. I'm your host, Jeffrey Hare, and I am very happy today to introduce JD Zamfarescu Pereira. He's a PhD student in computer science at UC Berkeley, where he's specializing in effective human-AI co-design. Now, previously, JD completed his bachelor's and master's from MIT. He then spent years in industry. He started a new company, which was acquired, worked at Google, and now advises AI startups. But in the meantime, he also embarked on a PhD, where his research examines new ways of designing with generative AI across different interface paradigms and levels of abstraction. He's the recipient of various paper awards and fellowships, and his work includes, last time I checked it was second most, but I think I'm out of date, now the most downloaded paper in the history of the ACM Chi conference, which studies how humans design LLM prompts and where they struggle. So please join me in welcoming JD.
Thanks. All right, thanks, Jeff, for that introduction. Can everyone hear me okay? In the back, yeah? Awesome. Okay, so I'm an HCI researcher, and I build systems and I use design methods to understand upcoming challenges in human AI co-design systems and hopefully solve them. And today I want to share a little bit about my work on using language in creating computing systems using generative AI. Before I do that, though, just to give a little sense of my trajectory here, I spent a number of years as an undergrad at MIT many years ago where, among other things, I discovered a passion for teaching, which turned into a nonprofit that I helped found. Ultimately, after college, I spent some time with some friends founding a startup. We built one of the first cloud computing platforms. We built one of the first server push architectures. Ultimately sold this to Google. Then I spent a bunch of years working on education technology, including this sort of instrumented JavaScript interpreter that shows you how code is run. I started a minor in essentially computer science in disguise at California College of the Arts, an art school in the Bay Area. I also had some failures. A short-lived video conferencing startup ended probably at the wrong time for video conferencing startups to end. And I've spent the last 6 years-ish at Berkeley in my PhD. And if you squint a little bit, I say all this because there's a common thread of collaboration here, and there's also a common thread of work ultimately about programming. And so now, in many ways, I'm living my best life because those two are the same thing that we are now also programming by collaborating with AI systems. And often, that looks like this, right? There's sort of this emerging vision of how you create something with AI. This is very much from my own life. I have a small child, and I'd like to create a game to help my kid learn to program. Learn to multiply. You might sort of come with this idea. You give it to an AI, an LLM of some sort. It gives you back a program, and you're done, right? This is sort of the just ask model of creating with AI. And sometimes it's not quite what you want, so you iterate, right? And now this process has a name, vibe coding, which is amazing. No thanks to me, but it's very convenient. And vibe coding is great if what you're doing has been done 1,000 times before in the training data for the LLM, and you can sort of see correctness in the code that it gives you, and there's a market of 1, and it's you, then it's fantastic. But if you're not in this circumstances, then I think we can do better. And so what I'd like to share is one vision for how we might do better, right? This could look like, in addition to sort of asking and then iterating, a system could sort of help you proactively explore some of the alternatives that you might be considering. It might then also help you understand how those alternatives sit in this broader design space of programs that you could create and help you feel empowered to make decisions in that broader space. It can help teach you about the space, the domain that you're working in, and help you discover new things about the world through the work that you're doing. And so there is a version here that goes beyond vibe coding, whether it's this one or another one. But if you sort of peel back the layers a little bit, often these visions are essentially, well, we've got a bunch of LLMs under the hood, and they're all kind of communicating in natural language, and ta-da! And so I worry a little bit that this empowering vision actually risks becoming this sort of disempowering cacophony, and I would like to try to avoid this outcome. So I'm going to talk in this talk about some ways that we might do that. My work over the course of my PhD has existed in several of these areas that I just described. I'm going to talk about 3 papers in particular today: Why Johnny Can't Prompt Herding AI Cats, and Beyond Code Generation. And ultimately in this talk, I hope to convince you of 3 things. Here's the first one. Chat is easy, but human-like interaction leads to misunderstandings and obscures capabilities. And I should say human-like interactions through chat with LLM models. Natural language is easy in part because we humans have tons of experience with it. It has flexibility, composability, you can use metaphors, it supports this nature of abstraction. But these actually aren't properties of natural language in isolation. They're ultimately properties of a system. Language plus speaker plus capabilities of listener plus the medium that you're working in. And if you're not, I should say, I'll leave that up for a second. If you're not paying close attention to this, you might end up with this problem, which is that Eitan Nadar at University of Michigan wrote this in a tweet, unfortunately, or I'd be citing it elsewhere. It says, don't let your UI write a check your AI can't cache, meaning that if your interface is presenting capabilities that ultimately your underlying system, your AI, can't actually meet, then you're going to end up with very frustrated users. All right. So how do we avoid some of this? So we realized really early on that about a year before ChatGPT existed, that GPT-3 was this sort of new kind of thing. And in particular, we realized that you could build a chatbot simply by asking for it to be a chatbot. It was really easy to describe the behavior that you wanted. You'd say, hey, I want you to be a recipe instruction bot. You'd pipe that into GPT-3, and you'd basically get a bot out of it. This bot had highly interactive dialogue. It was the sort of fluid, fluent language output. It supported a really long tail of user requests and preferences, right? So if you are, in fact, making a recipe instruction bot, you don't have to handle explicitly through callouts any kind of like, what if the user wants to make it vegan, right? This is sort of all part of the cultural knowledge that GPT-3 had accumulated. We also realized, though, that it was extremely highly sensitive to inputs, right? That you would need to engage in some engineering effort to get the kind of behavior that you wanted if what you wanted was not what the system provided by default. It's a little hard to remember this now because ChatGPT has become such a huge thing. But at the time, this was like GPT-3 was really kind of a niche tool that was, it had some press, but was like mostly used by like NLP researchers and folks kind of doing experimental things. I think we were fortunate in being one of the first teams to really recognize that this was going to become sort of a dominant mode of how we interact with these AI systems going forward. And of course it has, and there's all these startups and big companies, et cetera. And I think one of the reasons this work is like so highly cited, et cetera, now is because ultimately this is kind of the universe that has come to pass. Okay, so having established that we wanted to study this, how do we actually do that? And we think of this as basically being programming via natural language to define chatbot behavior. Our goal is to understand what prompt engineering is through a concrete example. The method that we're using is a technology probe. So this is a best effort system close to the edge of feasibility in a domain that we don't understand super well that asks, what are the critical challenges in this specific domain, and where do our best ideas succeed or fall short? So we built a support tool for making these task-oriented dialogue assistants called Bot Designer. And then we used Bot Designer to build actually a recipe instruction bot. Bot Designer itself, you could sort of summarize in the traditional iterative design process, right? You sort of design, insert your prompts. There's a big run button. You click it. And then you test your chatbot. You have a conversation with that chatbot. And then you can come back and edit those prompts and sort of repeat. This is what the actual interface looked like for the participants in our study and for ourselves when we used it later in an autoethnography. This is intentionally maybe too small to read, but on the right side, you sort of describe the behavior that you want, all in natural language. On the left side, you have a conversation with the bot itself. Ultimately, schematically, this is kind of what was going on. There's a bunch of pieces to that prompt. You pipe it into the LLM. You have a conversation. You come back. You make changes to your prompt. You pipe that into the LLM. You have a different conversation with the bot. You're able to label utterances that are sort of not what you wanted. You can retry those individual utterances to reflect changes that you made in the prompt in basically the program for this, for the chatbot. And we'd, in fact, built out this whole infrastructure for identifying whether or not a particular prompt change affects previously labeled utterances. This is a classic interactive machine learning approach here, right, where you're collecting a data set, you're labeling it, and then you're trying to see whether changes to your underlying model, in this case the prompt itself for the LLM, are actually affecting in good ways the sort of poorly labeled or labeled as bad utterances from the previous set. We had built this whole conversation viewer technique, visualizer as well that sort of shows parallel threads of conversation and tries to concatenate together where sort of these conversations meet at a particular point across multiple people. And I will say that building discount ChatGPT before ChatGPT existed meant solving some of the same tricky challenges that ChatGPT ultimately had to face, right? So there's too much text for the context window, right? GPT-3 had a pretty small context window, so this happened a lot. We would summarize prior utterances. We would sort of select from them by looking at their embeddings of these utterances and filtering using cosine similarity. This is sort of what basically underlies RAG now. Not that we invented RAG, but this is sort of the same technique, standard NLP technique here. One of the things that we did do uniquely in this project was one of the things we wanted to show in this, what we called the error browser, was whether or not utterances meaningfully changed in response to a prompt change. And so that meant, of course, answering the question of, well, what's a meaningful change, right? Like a one-word change that doesn't change the meaning of a sentence is not a meaningful change. We ultimately chose, again, the sort of cosine similarity metric, but now we're not clear what threshold is meaningful, and so we would ultimately fuzz these utterances to measure the distance threshold in the local embedding space, and then use that threshold directly here. So there were some challenges here, and then we used sort of the same approach for this conversation view. All of this to say is this was in support of creating this sort of relatively straightforward iterative design loop for generating prompts that describe a chatbot's behavior. Okay, so now that we had this tool, question is what chatbot to build. And for that, we turned to the internet, and we found this amazing web series called Back to Back Chef, which if you haven't seen before, I highly recommend, and I will show you a clip now, where there is one participant. Carla Lally, a test chef in the Bon Appetit test kitchen, would walk celebrity guests like Lizzie Olsen here through cooking a recipe, but critically, they would stand back to back and they wouldn't be able to see each other's stations. So this was like all through verbal instructions, and there was like a transcript available and all this amazing stuff, so that we really had like a source material to try to construct a recipe bot that was essentially acting as Carla in this interaction, walking the human user through cooking a recipe. I'm going to show you a clip here of this interaction, and I want you to pay attention to the kind of language that Carla is using, right? What is she saying? How is she saying it? What is she looking for? All right.
So the first thing we're going to do is take this very brain-looking giant mushroom.
Yes.
So this is a hen of the woods mushroom, also called a maitake. I got my squash and my lemons out of the way.
Okay.
Yeah.
Oopsies.
So the first thing I want you to do is just turn it over so the stem side is up.
Got it.
And then just use your hands to kind of break big clusters off of the bottom
Okay.
in like kind of large pieces, and then we'll go back in and we can make them smaller. And I like doing this with my hands because then you get...
Oh, you're not using your paring knife?
No, I'm only using the paring knife if it was like dry or
Got
seemed
it.
spongy at the bottom.
Okay.
We'll probably use like a quarter of these.
Okay, you get the idea, right? So it's like very rapid fire back and forth, right? Carla is being charming, she's being funny, she's checking in a lot. Like, well, how's it going? Like, you've got this and this. She's doing a lot of repair. She cracks some jokes, although we don't see that here, right? There's sort of all of these kinds of behaviors that you would want in a useful chatbot sort of in this context, but that you're unlikely to get from sort of a default kind of implementation here. And so ultimately we used both the bot designer tool as well as this source material across two papers. One is Why Johnny Can't Prompt, the paper that Jeff mentioned earlier, and the second is Herding AI Cats, in which we sort of did this ourselves, used our tool to try to get as close to CarlaBot as we could. So let me talk about this Why Johnny Can't Prompt paper first. I want to start with an example of what prompting is in the context of the study that we performed. So we provided participants with sort of a default baseline bot that was just like your recipe instruction bot, go. And so, running that bot is something that most participants did first, and they would get an utterance that looked something like this. I like using my hands because then you get a little bit more of that natural flavor in there. Maybe you don't love this utterance, and so, you might update the prompt and say, hey, don't say that when you use your hands you get a little bit more of that natural flavor in there. And out of curiosity, how many people have tried prompting these models before? What do you think is going to happen if you give it this instruction?
Unnatural.
Unnatural. No, in fact, you get exactly the same utterances before. Because although it is really tempting to think I said don't say it, right? Like anybody who's Had a small child will tell you that if you have a kid standing next to the wall with a crayon and you say, don't draw on the wall, right? You've essentially primed them to think of that as the right thing to do, as an option that maybe they weren't considering before. And so at this stage with these model capabilities, like saying something like this results in the same text that you had before. And what actually works here, and what some participants finally came around to, is that you actually just need to kind of identify when it is saying this, what is triggering that utterance, and provide an alternative, right? So this is not necessarily a super intuitive way of doing things, but it's not crazy out of the ordinary either. And so what we ultimately found in this study as we asked people to engage in this process is a bunch of human behaviors that come from these sort of system behavior models that are rooted in human-human social and instructional interactions, as well as some behaviors that we think ultimately look very similar to the sort of ad hoc experimentation that you find if you look at the end-user programming literature, at the interactive machine learning literature, which is that people overgeneralize from single successes or failures more than is really appropriate, and to the point that it really gets in the way. So to show some examples of this, there was a strong bias for direct instruction over inline examples. So even after we would show participants how effective examples were at getting specific kinds of behavior, for example, we'd say, we'd give them this kind of prompt text verbatim. It's include this in the prompt. Here are some examples of speech patterns to use. So the first thing we're going to do is take this very brain-looking, et cetera, right? Literally a quote from that clip. They would see this, they'd say, oh, that's cool, that's effective, and then they would continue just using direct examples and direct instruction and not using examples. They were very polite in their prompting, despite visible frustration. They'd be swearing at us, but please list only one ingredient at a time. And they really expected this notion of understanding rather than priming, which means that they kind of expected do not say ABC not to yield ABC, but it really does. On the program, end-user programming side and IML side, this premature failure declaration, this notion that non-compliance implies incapability came up a lot. So a participant might say something like, tell some jokes, no jokes in the first conversation that they had. They'd be like, oh, I guess it doesn't like to tell jokes, right? They wouldn't be thinking actually, I need to prompt it in a different way. I need to provide examples of jokes or some other mechanism for getting jokes other than just tell some jokes. On the flip side of this, they would also declare victory very often in sort of unjustified cases, right? So they would assume that limited success implies general success. They would observe an error, make one change to the prompt, rerun it, see that it was fixed, and be like, all right, cool, done, I fixed it, right? Not really comparing it to the previous conversations or understanding that that might have changed behavior in other contexts. And there was very limited interest in systematic testing. So this whole infrastructure that I told you about, how we sort of designed and built this sort of testing infrastructure, basically no one used it, which was disappointing. So what's going on here? What did we actually learn from running this exercise? Well, I think a big part of it is that aligning with LLMs just isn't like aligning with people. If we tease out the rest of this conversation, can we make this recipe vegan? Yes, you can use vegan bacon as an example of this. Can I just skip bacon? Yes, you can skip bacon. Would it taste as good? Yes, it would taste as good. How do you know? I know because I've tasted it, right? This is problematic, not just because it's false, but also because, someone who sees this is going to have lots of questions about, the trustworthiness of this kind of system. And then ultimately, part of the problem is it's not a lie, right? This isn't a lie exactly, right? A lie sort of requires this notion of an intent to deceive. Right? It's not like the LLM knows it had never tasted it, but somehow chose to say that anyway, right? That's not what's happening here. What's actually happening is that this is a dialogue that triggers these expectations of understanding, right? Of agreement, of reasoning, that in this case is sort of obviously false. And our notions, our triggers for these things that we have honed over years from human-human interactions just aren't reliable for LLMs. And Lucy Suchman has this great quote about this. She says, we tend to ascribe full intelligence on the basis of partial evidence. And so we assume more about the capabilities here because of the small amount of capabilities that we see. So ultimately, what do we do with this? And in this paper, we essentially made the argument that systems really shouldn't make humans rely on intuitions about specific things, in particular how LLMs and AIs think, what they kind of understand or know, what they can or want to or are willing to do, right? These are all sort of human notions that don't necessarily apply very well. And ultimately, we found that sort of default model behaviors, which we'll talk about in a second, and there's default human behaviors can work at cross purposes and be very frustrating. All right, so the second thing that I hope to convince you of, which we'll talk about now, is that prompt complexity limits how far users can steer away from default model behaviors. In this second paper, Herding AI Cats, we tried to use our own bot designer tool, and we did in fact use the sort of systematic testing piece of this ourselves to not go to waste, to try to get as close to Carlabot as we could. And I'm not gonna try not to bury the lead here, but really the question is, what is prompting LLMs like as a design process? And if you think of a traditional user experience design process as looking something like this is a famous design squiggle, not mine. You start from this place of uncertainty. You're prototyping, you're experimenting, you're talking to users, you're running all sorts of tests, you're learning about the domain, and over the course of this activity, you sort of go from this place of uncertainty towards this place of clarity and focus. And what we found in our designing through prompting LLMs is that, yeah, of course you still start in a place of uncertainty, but some uncertainty just seemed to persist, and there would always be these few sort of big problems that we weren't actually able to address. And then as we tried to address them more, actually we ended up in this waves of new uncertainty where some of the problems would cause these downward spirals, or the more sort of prompting we did, the more we would get sort of these previously fixed problems would reemerge. Our fear that other problems would emerge would actually grow as we did more and more prompt engineering here. And ultimately, we really felt like, unlike in a traditional process, there was just no guarantee. It was not clear at all that we were going to reach this point of clarity and focus through this process. And in the paper, we sort of speculate about ending up at a point of controlled chaos and being like, maybe it doesn't work for high-stakes domains, but maybe it works for fun. Which is not to say that it was all impossible. Yeah?
Can you go back? Yeah. Is this bad?
Good question. It depends on your goals, I would say, right?
Sometimes we have clarity, we feel clarity and focus when in fact we should not.
Yeah.
And sometimes we feel uncertainty when we should not. Mm-hmm. But I don't know, yeah.
That's a really good question. So I think definitely misplaced clarity and focus is not what you want to have, but also not what we had. We were not under the illusion that we'd figured it out. I think a lot of our participants in the earlier study were, but with our testing, it was very clear that we were not getting consistent behavior, and it was not clear to us how to actually get the behavior that we wanted. So I would say, yeah, the feeling of clarity and focus when you don't have it is bad. But I think the other piece is, maybe you're asking the flip side of this too, right? Which is is it, are there situations where it's actually okay to not have this?
Maybe you get a better outcome because you're never complacent. You kept on your toes always, and so you do a better job in the end? I don't know.
I think that's probably true if you are the ultimate user of the sort of outcome of this process. But that's not how we were thinking. That's not how we were conceptualizing this process. We wanted to create something that we could then give to other people, which I think has slightly different expectations than that. But no, I agree with sort of at a high level that if you're making something for yourself, this is designed for one, then sure, why not, right? Yeah.
These seem to be for GPT-3. Does any of this?
We'll get there. Yeah. So what happens in the GPT-4 and the 4.5, et cetera? I'm gonna put a pin in that because I have a whole section on that. Okay. Okay. Which is to say, and before I get to that, I want to say this was not all terrible, right? If you use these models, you know that they for a lot of things are not that bad, and that was true here also, right? If we wanted the sort of detailed visual instructions, we could just add those to the recipe, right? You just put that text in the prompt, done. It's going to produce that text. It's not sort of an issue there. If we wanted Carlabot to confirm user progress, we could just kind of ask for that, right? If we're continuing, ask the user, do you have smallish pieces? And we would get that as well. There were other things that were a little trickier. The sort of error recovery was harder. We couldn't just say recover from errors. We had to sort of figure out a way to convince the model through a prompt that actually the user was like an amateur and needed like extra help, basically. But ultimately, this kind of worked also, even if it was a little hard to find. But part of the challenge, even from the stuff that was successful, is that we ended up with this like tightly scripted dialogue anyway, which if you recall from the top of the talk, part of the whole reason to use an LLM to create a chatbot was, it like covers all these edge cases that like you don't have to explicitly program. But in the end, we like ended up explicitly programming a whole bunch of edge cases into here, which made it feel like, what was the kind of the point of this exercise? And then once you have this tightly scripted dialogue, which by the way, this isn't just us, right? Like if you look at any of the prompts that have been exfiltrated from any of these like Apple Intelligence or Sydney or whatever, these large systems, they're all full of this like, yes, do this, no, don't do this other thing, right? This sort of litany of ways they're trying to get their model to behave differently than sort of what it was originally trained for through this prompt. And so once you have this large prompt, then this prompt design process, this prompt engineering process becomes really challenging. Because if you want to add another message to this prompt, where do you put it? And depending on where you put it, like you might end up with interactions with like other parts of the prompt that may lead to undesired behavior somewhere else. And it was in fact those sort of long prompt interactions that drive challenges here. You might have two prompt components that sort of individually work, tell a joke, get a joke, only this one instruction at a time. You get sort of a single instruction at a time. But then when you had both of these in a single prompt, you would get like neither behavior, right? Which is, as you can imagine, is quite frustrating. And ultimately, I think, thinking about like what's going on here and what did we learn about this prompt engineering process, there are some common prototyping assumptions that start to lose validity at scale. And in particular, you often expect if you're making a small change in one place in a prototype that, it's going to the scope of that change is limited to that one place maybe. But here we often observed like a major impact somewhere else in the system. This meant that there was really limited modularity, right? As an engineering principle, it was really hard to like actually sort of subdivide these components. It was very hard to separate concerns here. It was this constant game of whack-a-mole where we'd like fix one problem somewhere and that would cause some other problem to reemerge, as I mentioned earlier. It was also really hard to get guardrails. So, this kind of like haha funny example, right? Like it's very hard to get it to actually not make these kinds of statements, right? Like we could not actually get it, like for any one of these, we could figure out things to say instead, but there's always this sort of long tail. All right, so this is to your question earlier, like, but wait, aren't models actually getting better at following prompts? And like between when we submitted this paper and used, GPT-3.5 for this particular version, like GPT-4 had come out. So of course the reviews were like, what about GPT-4, guys? And of course, like, we tested with GPT-4 for the camera ready for this paper. And like, of course, certain things were better, right? Better social conversations. The jokes were better. There's more empathy. And yet, there were other things that were not better. The system was more verbose, and this was like actually really hard to fix. Trying to get it to say just a single ingredient at a time proved impossible. And if you work in ML and you keep up with this stuff, like one of the big reasons for this is that techniques like post-training techniques like RLHF are incentivized to give you complete responses, right? Which is great if you're doing something like ChatGPT, and ChatGPT is like now trained to give you complete responses. But if you want is a sentence fragment, you're going to have a lot harder time getting the model to give you a sentence fragment because that's been trained out of it, right? And so ultimately, I think this question of aren't models getting better at following prompts is maybe the wrong question, because it presumes that these challenges are actually rooted in models' prompt adherence. But prompt adherence is actually mediated by prompt complexity, and that's not just about limited model capabilities, right? And when I say prompt complexity, I don't just mean like that long sort of single prompt, but if you're like having an iterated chat, you're having a conversation, you're refining things, you're doing chain of thought, you've uploaded PDFs, right? These are all part of prompt complexity. It's also about how far you are trying to steer away from the default behavior that the model was trained for, right? And unlike capabilities, which you could sort of convince yourself are like getting better over time, right? Like GPT-5 will have better capabilities, 6 will have better capabilities. It's not as obvious what that means for like default behaviors, right? Like a model has a default behavior. Like it doesn't have like a default behavior that is growing over time. That doesn't necessarily mean something, right? Models' default behavior is like, are they getting better for every use case? Well, they can't, because there are contradictory use cases that need different things, right? So it sort of just doesn't really make sense to ask that particular question. But I think instead, maybe the right question to ask is some version of this, like, how do we actually navigate the complexity of creating these prompts to steer behavior when we want to? And so for the last part of this talk, I want to talk a little bit about navigating this complexity through intermediate abstraction. So this is grounded agreement and proactive exploration are two techniques that we used in this most recent work. Okay, so this is a project where we tried to do explicit support for program design, building a tool that was, not for chatbot design anymore, but instead for just like regular program design. Now what you're looking at here is not what we built. This is GitHub Copilot. And this is probably what most people think of when they think of like AI-supported programming. They think of something like an autocomplete where you write a function declaration and you get its definition, or maybe there's a chat and you can like explicitly ask for a certain functionality to be created, like unit tests or something like that. We were interested in pushing past that, sort of just code synthesis, code generation, and thinking about program design more broadly. And so what is program design? If you imagine like a data scientist, they're maybe working in a Jupyter Notebook or some other sort of platform. They might start with a question like, what's the relationship between these variables? And then they might discover that there's like some data missing, and they need to like shift their question to consider some other variables instead. And then try to figure out like if they can triangulate sort of original relationship of interest from this like new, right? This is, common process in the data scientist workflow, and is, that's not about code synthesis. That's not about writing the code. These are all sort of questions that arise that are separate from the actual writing of the code. Or if you consider, like a parent or a worker at an ed tech company, an engineer at an ed tech company, right? They're asking lots of questions and thinking about lots of things other than the code of whatever educational technology they're trying to make, right? So maybe they're making an educational game and they're thinking about how do they achieve their educational goals? Like, who are in fact the users of this system? How do you maintain the focus and attention of a child, right? Is some storyline pedagogically relevant? Or are a certain set of characters like relatable for the specific user of this system, right? So these are all kinds of questions that are important and relevant when you're doing programming, but aren't the actual synthesis of the code itself. And so in this project, we ultimately had two sets of goals. First is a set of design goals. We wanted to actually support program design processes. And so what that meant in part was that we wanted to help help users abstract up to higher level design goals so that they could broaden the design space exploration that they were doing. And we wanted to support them being able to design programs sort of across levels of abstraction. And in part, one of the questions that we wanted to answer is how and when can this design support be useful? And then we had a second set of epistemic goals that are really about human-AI interaction. And we wanted to see if we could address certain known human-AI communication challenges, like the ones that we've been talking about so far, by tracking goals and decisions explicitly, by proactively exploring alternatives, as I mentioned at the top of the talk, and asking whether we can avoid some of the LLM pitfalls while still harnessing some of the many capabilities that these systems have. And of course, what new challenges emerge if we start making progress in that direction. So we, schematically, again, you can sort of think of the work here as sort of taking this original model of I start with a prompt, let's make flashcards for multiplication practice. I give this to an AI as an AI language model, here's some code. Then I sort of look at that code, I run and I assess this point solution, then I update my prompt and I repeat, right? The sort of vibe coding or just programming with prompts or chat. What we wanted to do was to go a little bit further than that. So you still start with an initial prompt, but now you sort of have this initial discussion with the AI that leads to abstracting up to like a higher level question. Like the AI will ask you, what's your higher level goal? And then you may have started with, let's make flashcards for multiplication practice, but actually your goal is to help a 5-year-old learn how to multiply small numbers. And then once you've established that higher level goal, the AI can also help you, so Pale in this case, our system can also help you try to understand what questions you should be considering. It'll generate questions for you that are related to your goals, like what would keep your 5-year-old motivated and interested. It will actually provide multiple examples of code that will meet some of those requirements or will help you understand some of those requirements. Here's an example matching game with farm animals, for example. It will help assess why you might want to choose one alternative or another, or consider what you might want to be thinking about in the design of this system. And then ultimately, we'll provide a bunch of alternatives that you can select among if you want to choose one of those for any of these questions or designs that it generated, such as like use single-digit numbers, drag and drop, use the drag and drop input style, right? It sort of provided mechanisms for you to select from, or you can, of course, suggest your own as you go through this iterative design process. And so I'm going to show you, we call this tool Pale. I'm going to show you a little bit of a demo of this. So you still sort of start with the original prompt. Is that a timer from me? No. OK. All right. Start with an original prompt here. And then you're having a conversation. The system suggests some things that you might want to be thinking about, like goals and desired outcomes, as I just mentioned, who the target users are. And then in parallel, it pulls out some of those questions and some of what the requirements might be from that conversation into this design panel. And this design panel is essentially a way of tracking where the conversation is at, right? So instead of just having a lot of these decisions sort of lost in the ephemerality of chat, they're actually pulled into this side panel so that you can literally inspect them and select among them. And that sits in the context that's provided to the LLM so that, again, it's sort of not lost in the ephemeral context. OK, so here's an example. What specific multiplication skill should the game focus on, right? As a design question that seems relevant to the initial prompt here. There's a possible solution offered. If you hover over that possible solution, you'll get a rationale for why you might want to or might not want to choose that particular solution. You can hit the try button, and it will actually go ahead and say, oh, OK, sure, let's use single-digit numbers. Let's try that and see what happens. Any of these sort of confirmed requirements you could click on, and there's this set of generated alternatives to that requirement, right? So you're no longer sitting there thinking about all the alternatives yourself necessarily. You can rely on the AI to give you some alternatives, and maybe you like one of them, or maybe you don't, but you have some other idea. They spawn some other idea for you. Over the course of some amount of time, then, participants in this study or users of this tool would eventually get some code written. And in generating the code, there's a bunch of work here designed towards trying to help the user keep track of the changes that are being made, not just through diffs, of course, not just through changes to the code, but through summaries as well of what has changed. And then sort of a clip from later in the process. But over the course of 15 to 20 minutes, the users would eventually get, participants here would eventually get to some version of something that addressed one of their high-level goals that they came to with the AI. And so in this case here, this is like a farming matching game for multiplication practice where you drag out the number of plants in sort of a multiplication style, right? 4 times 2 is 8. There's 8 plants. Ta-da, you've got 8 plants sort of to practice multiplication. Not flashcards after all. All right. So this is roughly what the tool looked like. So what did we find from actually doing this? We asked a bunch of participants in a lab study to create several different kinds of interactive artifacts over the course of 60 minutes. And what we found on the design goals side is that, sure, yeah, design support helps broaden design space exploration. Yay, OK, cool. We set out to accomplish to some degree what we originally set out to accomplish. All participants considered, attempted some Pale suggested alternative. And so we were glad for that, but that was kind of ultimately not necessarily the thing that we were doing for the work. We wanted to understand how this design process might change. And one of the things that we saw is that the activities that they were engaged in were not just all pragmatic, they were also epistemic, right? So they were testing, they were sort of making progress in understanding the domain in parallel as they were actually making progress in creating prototypes towards the goals that they had. And then on the epistemic side, right, we were sort of trying to understand more about human-AI communications here. We found that actually having this design panel meant that this design-grounded knowledge was actually more effectively persisted, right? It sort of helped keep track of the kinds of goals that were specific to the project, that were discovered through the conversation, through the prototypes, compared to just having them be present in chat. There was this rapid iteration that participants would go through between code and chat and trying these alternatives in the design panel. They were able to design across levels of abstraction, manipulating the code directly, but also sort of choosing from the alternatives in that panel. And in a sense, it was as though what would normally have been a longer design process was really compressed in time, right? Not all rainbows and ponies, however. There were many challenges here, and one of them in particular, as you probably noticed while watching that video, is that the information quantity here is quite overwhelming. In fact, most participants said something like, each time I click on something in here, I'm like, what part of this is important? any focused attention that they had was really spread thin across the code and the chat and this design panel. And awareness of the code, of changes to the code, of the changes to the design, like once it was lost, it was hard to regain, right? So once if participants were paying attention to what was happening, they would pay attention to something else, or they would stop to talk to us, and then they would sort of lose track. And they often felt like it was hard to then follow up and see what had happened. Experts found it easier to do this, so expert programmers, folks who had a lot of experience programming, but basically none of them actually managed to maintain awareness of the whole thing throughout the entire study. Ultimately, it felt like users wanted to be able to look at the code, but not to have to look at the code, right? Which I think is maybe one of the lessons of vibe coding as well. And the sort of domain and programming expertise impacted this perception of surprises. So as they were keeping track of the changes that were being made, there's this very Don Schoen moment of they're sort of following along, they're looking at what's happening, and then something would happen that was unexpected. And that's where they would stop and reflect and intervene. And to the extent that they could understand what was happening, right? When they could understand what was happening, they were surprised. When they could not understand what was happening, it was not clear what a surprise would mean in that context. Okay, so we ultimately ended this paper with a little bit of a now what. Pale is one way really to blend LLM chat with grounding in these artifacts of program code, in this metadata, and this design space exploration support. But maybe it actually raises more questions than it answers, right? Maybe some of the questions here are how can we actually identify and match information to users' level of expertise? And this might be something that even shifts over time as they're using the tool or from week to week, right? How can we support user attention and keep users informed? What information are we actually showing to users? And when should systems demand attention? Should they say, hey, no, actually, this is something that you now need to pay attention to. You can't vibe code this. This is important. You need to understand what is happening here so that you can confirm it. And frankly, if even when programming basic apps like this, it's hard to keep up with information flow. Is there actually any hope that people can do this for more complex systems? Okay, so I'll give you a set of takeaways for this project as well. It's great that Pale's affordances supported iteration at and across the multiple levels of abstraction and engaged in broader exploration. We saw that expertise matters and defines how systems should provide feedback and insights to users. And this compressed in time design process, right, activities that would normally have taken several hours at a human timescale, when compressed in time can lead to this information overload, right? I think it's not just the fact that the human themselves isn't doing it, but the fact that it's all coming in the span of 10 minutes, otherwise would have taken a lot longer. And I think this really points to a key challenge for these kinds of systems, which is managing and directing user attention and information flow, not challenges that we typically associate with IDEs. Is really pointing the way to the work that I would like to start doing now, which is that keeping humans in the driver's seat as we increase the complexity of the kinds of systems that we're building requires showing users the right information. And we don't really understand what that means right now. One way I'd like to explore this question a little bit, again, with a technology probe, right, is thinking about how we can scaffold better communication and think about a notion of distributed cognition with AI. And so in new domains, right, Pale does this a little bit in the programming domain, but in new domains, what do we need to actually capture from that conversation in data science, in game design, in writing, so that as you go through this iterative loop, you can have these higher level abstractions that then you can iterate on and work through. What alignment structures really help the humans build more complex systems here with AI support? How can this communication and action be more legible to the human so that it's not just this ephemeral chat still that's there? And ultimately, how can we actually blend the stochastic natural language interactions that we're getting from chat with these more deterministic algorithmic interactions that we've spent decades creating? And then for the second project, I think is a little bit of a build off of that one. One of the big challenges in using larger models or interconnected models, which I sometimes call assemblies of agents, is that they produce a lot of noise, right? That you ask, especially if you've got multiple models kind of talking to each other, they will very rapidly come up with requirements that you actually did not have. And so as those things propagate, you get worse and worse outcomes out of this. I think, though, that we have strategies for addressing this kind of thing in computer science. And one of them is the robustness principle, right? This idea that you are conservative in what you send, but liberal in what you accept. Every node in a network cleans up and reduces noise. And so what would that mean in the context of a network of LLM agents? Well, you've got sort of data coming in from the prior node. You've got the overall user goal. But I think part of what's missing is what does it actually mean to clean up in this kind of environment? And I think it, through some of the other work I didn't present here, we've discovered that humans often have implicit validation metrics, meaning that they have notions in their mind of what a correct answer will look like that they aren't actually expressing. But maybe we can make those explicit and then use them to sort of steer the individual output of any particular node so that that cleaner output reflects sort of the implicit validation metrics that an individual human might have. And I think this, too, could potentially be used to support sort of more complex programs in a legible way. All right, so I think now I will leave you with a set of takeaways for my whole talk, which is that just asking an LLM as if it is human is easy but limiting and not really solved by better models alone. We ultimately need new design patterns and frameworks for these interactions, things like grounded agreement for working across abstraction levels, as we saw in Pale. But we also need strategies to keep humans in control in an empowered capacity. We can think of things like metaphors like informed consent in other contexts there. All right, so leave my slide with my picture of my collaborators, and I'll thank you for your attention and happy to take any questions.
Okay, we now have time for questions. People have some. I don't need to pass the microphone around because we have microphones throughout the room, so just please speak clearly when you're chosen. Yeah.
Hi, I'm Kate. Thank you so much for your talk. That was very interesting. Kind of going towards the point that you got to the end, I've heard anecdotal stories from vibe coders that they're using tools like Windsurf and Devin, and starting with a test-driven development framework. Have you given any thought into that? Because you started to mention the validation component, but yeah.
Yeah, I mean, I think, not to be tongue-in-cheek, but it sort of depends on what you mean by vibe coding, too. It's at a certain point, right? So, like, if you know what you want in advance, and you feel like you have a mechanism for specifying that in advance, that is a huge advantage. But it is not omnipresent in sort of design problems in general, right? Often we don't know what we want, and we are trying to learn through the creation of the artifact what we actually want. And I think in those circumstances, it's a little bit trickier. We might still have some notions of what we want, right? Some sort of implicit notions of what we want, which is kind of what I was trying to get at in that last future work slide. But yeah, I mean, it's sort of an interesting question of whether there are like more effective ways of going about doing this kind of coding when you do know exactly what you want, right? Or it has been done a bunch of times before. Yeah, I don't know that I have any like super concrete thoughts about that, but I feel like maybe other people are solving that problem too, like like Windsurf or Cursor or Devin. Yeah. It's a good question though. Yeah. Anyone else?
All right. Well, while we wait, I have a question.
Yeah.
I enjoyed seeing sort of the compressed design cycle in Pale.
Yeah.
And it got me thinking, what would happen if I then try and repeat this process with a new problem? Would it start to feel very similar and patterned or more dynamic? So I wonder if you could speak a little bit more to the design process behind how you then operationalized a design process. So basically how static or dynamic was the underlying workflow. Were there particular tricks or insights you had to try and help it arrive at more helpful suggestions and different recastings of problems as people went through those iterations?
Yeah, that's a really great question. I feel like one of the things that's not present in Pale is any kind of like meta notion about design process, right? Like it was all very hard coded into there. We essentially said in the prompt, like, hey, the first thing you should do is like ask the user what their high level goal is, right? And so that works fine for this particular context, but that's not going to be like a commercial tool or anything like that. I don't know that I have an amazing answer for that question either. I suspect that to some degree it's going to be context specific, right? So, are there sort of generalized prompts that you could use or generalized workflows? You could probably import some existing design processes and try to operationalize them into like an LLM or like a chain of LLMs or something like that to sort of elicit the kinds of questions or the kinds of thinking that you want early in that design process. Because ultimately what it's really about, I think, is steering sort of humans thinking through what we understand the design process to be for that particular domain, right? So for Pale, it's program design. It's a sort of very concrete kind of thing that we've done 1,000 times before in some ways. The process, that is, not like the specific outcomes. But if you're like, if you were going to do something for writing or whatever, or for like, OpenSCAD or some other kind of environment where you have a very different kind of output, I suspect you would want, if perhaps a similar process, right, you're probably not thinking about the end user when you're like designing a gear for some kind of mechanism, right? So you would want to think about like, well, what are the specific questions for that? But I mean, I don't know if that's like a particularly insightful answer to that question, but like, I suspect it will be pretty context specific. In terms of like, what is the specific tool asking the user to consider over that life cycle? But I think the sort of broader notions of what are you actually then retaining from those conversations? What is the set of explicitly epistemic actions that the user is taking in that conversation? Are there sort of general principles in how we pull out the specific sort of learnings, the lessons from that conversation, reflect them to the users, record them, right? Like in the programming context, also, it's not obvious that sort of a list of like text bullet points of, confirmed requirements is the right visualization for a set of requirements, right? Like if you've got like a system that's being designed, you might want a system diagram or something like that sort of reflects a more effective way of thinking about the structure of the program. I mean, I think it's a super interesting question. I suspect I personally would want to try a few different domains here to see if there are kind of generalizable principles that we can pull out.
Yeah, that makes sense. I think the audience of users matters tremendously too, in terms of like what you would do for professional software engineers who have existing
100%.
collaboration patterns and workflows would be very different than from what I took to be more of an end user programming type scenario here.
Yeah,
I want to
that's
open up for
absolutely
questions from others. Should I use the mic? No. Well, if you want to, but we have mics throughout. Okay. Since you're masked, it might help.
Yeah. Cool. Thanks for the cool talk. I'm intrigued by the sort of possibilities of sort of drawing on distributed cognition theory that you mentioned toward the end. When I think about it, I think about distributed cognition as sort of making an argument for cognitive processes like, perception, recall from memory, computation, storage, error correction, things like this as being distributed across systems of people, artifacts, et cetera. And one of the things that's interesting to me about a lot of the decog literature is it almost exclusively studies routinized processes, not creative processes. And so I think there's not a lot in that literature that could inform how do we think about decog as a framework for creative design. And yet, it's exciting that you're thinking about it as how could this be useful to us as a framework for building creative design tools. And so I'm kind of curious about where you see that going. What's the distribution of activity, representations, et cetera, across people and systems that you envision that would be most felicitous to creative design?
Yeah, that's a really good question. I think that honestly, creative design is a combination of routinized processes and sort of like non-routinized processes in a sense, right? Like there are the parts of design, there's like the individual sort of prototype construction that, maybe is more routinized. And then there's the, actually assessment that you're doing sort of, maybe engaging in like more sort of rational evaluation of what you're seeing in a different way that maybe isn't as. And I think, honestly, part of the question is how do you combine those two effectively, right? Like this is, sort of a parallel to this question also, right? Is like, what is the actual way that you can take advantage of the fact that you can now sort of not only have, the set of artifacts that are sort of static and geared towards like this one process, but that you can now generate new ones that are maybe, similar enough to the ones that you're familiar with that are like, being created bespoke for the specific type of like construct that you're trying to engage in, specific activity you're trying to engage in, and then like learn how to use those so that it does maybe become more routinized for that like particular like environment or context or whatever, right? Like, and I don't have a good sense for how generic these will be. I mean, this is kind of your question earlier, right? Also, like how much of this is going to apply broadly across contexts and domains and across user expertise and sort of across these other differences that we bring in each of these design. I don't know. I don't have a good sense for that. I mean, I hope that at least some of those patterns will sort of continue and emerge and repeat themselves. But I think we're just in very early days of what this means. I don't know. Maybe that's not a very satisfying answer.
It's a fine answer.
Or you can just speak.
Okay, I'll speak. Thank you. Great talk. Really love your work. So I feel like, especially this last bullet point, I really like of blending the stochastic like natural language with the deterministic side, and it feels like you've really focused on the model side, like holding the model static and how do we deal with that. But there are also interventions where you can maybe change the default behavior of the model, either by like constrained decoding, where you're telling it can only, or like some sort of very localized fine tuning like LoRa or whatever. Have you looked at those, or are you interested in those at all?
I am interested. We haven't looked at them, but only because of the sort of constraints of we had to pick a certain set of things to do, and we had done a bunch of prompt engineering work already, so we were kind of familiar with it. We have tested fine-tuning and sort of other, for the Carlebot paper that I mentioned earlier, the herding AI cats paper, we actually did a bunch of fine-tuning to see if that was an easier way or more straightforward way to get the sort of verbal behavior that we were looking for from that bot. It turns out it was great. But like, you need to have a bunch of data to do that, right? And sort of in contexts where you have that, fantastic, it's another tool in your toolbox. In contexts where you're sort of making it all up on the fly, like you are in Pale, like you kind of don't have that. So, as a designer of Pale, it was sort of one thing to consider. Does it make sense to like actually iterate on that model in a way to make it more effective for some specific design task or for some context? But it's sort of harder to imagine for the Pale context what you would gain from doing it in the loop, right? Other contexts, for sure. If you were like working in architecture and you're trying to do like, building plans and you've got like a set of like, existing design language basically from the city or whatever that you're trying to match, like, for sure, maybe that is more effectively used in some kind of post-training loop. But yeah, no, we haven't looked at it a ton.
Thanks.
Yeah.
Okay. Thank you, everyone. Thank you again, JD.
All right, thanks all.